This diary will contain all the topics for network theory. So please listen and see carefully. All the best. Today we will start with topic 14. So what is topic 14? Topic 14 is nodal analysis. So this is also a technique to solve questions of basic circuits or any circuit. If you want to find out anything, then you can solve using this method. So let me take one example here to illustrate this method, and I will also tell you shortcut after making you understand this method. Okay, this is 12 volt voltage source, and this is 1 ohm resistor, and this is a current source of 4 amperes, and there is also one more resistor as 3 ohms. Now what actually the question can be anything, like find the current across 1 ohm resistor, find the voltage drop across 1 ohm resistor, or find the current across all the elements of this circuit. So anything, so you can find out anything. If we find out the node voltages. So in this method our objective is to find the node voltages, and I have already told you the concept of node voltages. So as I have told you in my previous video, that node voltages, you can only find node voltages if you know the reference node. So in such questions, if you want to solve using nodal analysis, first you have to assume the reference node. So step 1 is assume the reference node. See, there is no logic behind assuming the reference node. You can assume any node as reference, but with practice you will understand, or you will come to know that that by choosing certain nodes in a circuit, the calculations become easy. So here I will choose, see how many nodes are there, 2 nodes only, one this and one this. So I will choose this as reference node. So reference node means the potential of this node is 0. And what again I will assume, step 2 is mark the node voltages, the rest node voltages. Rest node voltages means, see, like here there are 2 nodes. So one node you have to assume reference. So this I have assumed reference. So how many nodes are left in this circuit? Only 1. So I will mark the voltage at this node as VA. Let's say VA. If there were other nodes, then I would have marked VB, VC like this. So this is I am trying to say. So this is step 2. That is mark the node voltage. I assume that it is VA. Okay. Now here, what is our third step? Now we have to write the KCL at each node, and this VA we will calculate with respect to the reference node. This I have already told you, that node voltages are calculated with respect to the reference node. Okay, so my second step will be to write the Kcl equation at each node, assuming that the particular node is at highest potential. Okay, so step 3 I will write it down, it will be more clear to you. Write the KCL at the nodes, assuming that the node potential is higher than other nodes. So in other words, we can say that we will assume that current is coming out of node at which we are writing KCL. See, this I am writing just to give you a sense of clarity. It will be more clear if I write it, if I write the equation directly. See, what I am trying to say is, see here there is VA. So I have to write KCL at this node. So what I will assume that the potential of VA is greater than rest of the nodes available in the circuit. So obviously the reference node voltage is 0, so VA is already greater than 0. Let us say if there is some circuit like this, 3 ohms, and so this is also one node, so I will mark it VB. So what I am trying to say, if I am writing KCL at node A, then I will assume that VA is greater than VB. If I am writing KCL at VB, then I will assume that the node voltage VB is greater than VA. This I am trying to say by writing these statements. Okay. So this is the logic. So let me go back to my original circuit and let us write the KCL. So if what I have to assume that the current is coming out of this node like this, because this node is at higher potential. So write out KVL. So I have told you that entering current is taken as negative and leaving current is taken as positive. This is the convention that I have been following throughout the subject. So it is simple. I have learned it like that. You can take it otherwise also. It doesn't matter. Okay, so I'm assuming that all the currents are leaving this node. This we have to assume, and I will write the KCL. So see, what is the current through this branch? So we can write KVL across this. So this, let this node be VG. It is 0. So what if you write the KVL across this? I have told you, simple. VA minus VG we have to write out. Okay, write out KVL for this branch. Okay, just write out KVL for this branch, and let us assume that the current is I1 here. Let us say I2. Let us say this is I3. See, this I am just marking just for your understanding. It is not necessary. So I1 plus I2 plus I3 is equal to 0. This is our KCL. Now write I1 in terms of these elements. So now look at me carefully. See, this is the branch I have to, I1 is flowing from VA to VG. So write out KVL for this branch. I have told you in my previous videos how to write KVL when the circuit is like this. I will assume VA minus VG. So this means I have to go from G to A. So go 12. This will be plus minus plus I1 into 1. So what is I1 from here? VA minus VG. VA minus VG by I1 will be VA minus VG minus 12 by 1. So it can be written as VG is 0. So VA minus 12 by 1. That is I1 is equal to VA minus 12. Okay. So this is how I have found I1. Similarly, I am rubbing these steps so that we could find the equations for I2 and I3 similarly. So this I have told you before how to write KVL. I am hoping that you have watched previous videos of this playlist, so it will be easier to understand. So I1 is VA minus 12. Now let us write I2. See, there is already a current source, so I2 has to be 4 amperes. Simple. Now we will write I3. Again I3, VA from current is flowing from A node to ground. So we have to write the KVL. So write KVL, move from here. It will be plus minus. It will be I3 into 3 is equal to VA minus VG. Simple. So VA will be equal to, I3 will be equal to VA by 3. So this is our I3, this is our I2, and this is our I1. So write out, substitute these values in this equation. So what you will write, what you will get, the KCL at node A will be, substitute values of I1, I2, I3 in this equation. So you will get VA minus 12 plus 4 plus VA by 3 is equal to 0. Simple. So what it will be, VA plus VA by 3 will be 4 VA by 3, minus 12 plus 4 will be minus 8. So 4 VA is equal to 24 by 4. 20 VA will be 24 by 4. VA will be 6 volts. So VA comes out to be 6 volts. So see, now what is the benefit? When VA comes out to be 6 volt, now we can easily find current through any. See, I1 I can find out directly. VA minus 12, that is 6 minus 12, that is minus 6 amperes. So I1 is minus 6 amperes. I hope you know clearly if it is coming minus 6 amperes what it means. Okay, I have told you before all this, so I won't tell you again. Please watch my previous videos in this playlist. See, basics are very important. So I1 is equal to minus 6 amperes, I2 is equal to 4 amperes, we already know. I3 is equal to, what is I3? VA by 3. So VA 6 by 3, that is equal to 2 amperes. Okay, so I3 is equal to 2 amperes. So what is the voltage drop across 3 ohm resistor? 6 volts. What is the voltage drop across 1 ohm resistor? If I am taking these polarities only, then it will be minus 6 volts. So this way you can find any parameter for any element in this network. So this is what is nodal analysis. In nodal analysis, what we do, we find the node voltages, and you already know, I have already told you before, that node voltages only stands when there is some reference node. Okay, now we will see one more good example, and through which we will learn the shortcut. It will be more clear to you. Let me draw that network. So this is the circuit for which we are going to write the nodal equations, and we will use the short trick. Okay, so first step is same. Identify the number of nodes. So there are 3 nodes, 1, 2 and 3, and then mark the reference node. So I am taking this as reference node. This all is one node. Okay, and I am taking this as VA. This I am taking it as VP. Okay, so now first write the KCL equation at any node. So we will write KCL at A using shortcut. So first write VA like this, then write VB like this, then write equal to. Okay, now see all the elements except the sources connected to this node. So the element 2 plus 1, 3 ohm is connected here, 3 ohm is connected here, 4 ohm is connected here. So just simple write 1 by 3 plus 1 by 4 plus 1 by 2. Okay, and then see, these are the self elements, that is the elements that are connected to the node. Now take the element that is connected between this node and the other nodes, that is VB. So there is only 4, so it will come like minus 1 by 4 VB is equal to, now we will take the sources here. Now how to take the sign of sources, these I am writing the rules here. Okay, for sources. So first for voltage source, see, if positive of the voltage source is connected to the node, which node? The node at which we are writing the KCL. So now we are writing the KCL at node A, is taken as, if positive is connected to the node, then it is taken as positive. If negative is connected to the node, which node? The node at which we are writing KCL. So if negative is connected, then it is taken as negative. Okay, the rule for current sources is, if current is incoming from the node, which node? The node at which we are writing KCL. So if the current is incoming, then take it positive. Current is incoming means that is current is entering the node, then you have to take the current as positive. If current is outgoing from node, then it is taken as negative. Okay, so this is the rule. So now we will write our equation. So now let us see. to VA, this 10 volts is connected, so plus is connected to the node, so 10 will be taken as 10, and we are writing the KCL, so it has to be current. So 10 divided by the total branch resistance to which that source is. The 10 volt branch is this, so 1 plus 2, 3. Now minus is connected, so minus 20 divided by the total resistance of this branch, 3. Then this plus 30 divided by 4. So this is our first equation. Okay. Now we will write our KCL at B. So KCL at B, same VA, VB equal to, or I should write it VA here, so it will be better clear to us. Okay, equal to, so now see VB. To VB, what are the elements connected? 4, 5 and 6. Okay, so what we will do? I will write here 1 by 4 plus 1 by 6. See, I have not written this 5. Why I have not written this 5? See, don't take that resistance, the resistance of the branch in which the current source is there. See here 40 ampere current source is there. So you don't have to consider that branch resistance while writing equation here. So please remember this. That is why I have taken this problem. One gate question is also there on this. Okay, so this is a trick. Just learn it as a trick. It is not any logical concept. So 1 by 4 plus 1 by 6. I am not taking 5. Now take it to VA. So VA, this is the mutual element is only minus 1 by 4. So it will be minus 1 by 4. So mutual element is always taken as negative. Mutual means that is connected between the two nodes. Okay. See here also I have taken it as negative because 4 is connected between VA and VB. So equal to what? Now see, minus is connected, so minus 30 divided by 4. Minus is connected, it will be minus 50 by 4. Current is leaving the node. Current is outgoing from node, that is leaving, so it is taken as negative, so minus 40. It is only a current, so we don't need to divide it. Okay, so this is our second equation. So on solving these two equations, we can find VA and VB with respect to this reference node, and once we have found out VA and VB, as I have told you before, we can easily find out any parameter for any element in this circuit. So thank you guys. Please like, share and subscribe my channel, and please like this video. Okay.